Hello to all my viewers. This is Dr. Dhaval Maheta, and today we are going to discuss how to test convergent and discriminant validity of an instrument in SPSS. Validity refers to the degree to which an instrument accurately measures what it is intended to measure. Validity is essential for ensuring that the conclusions drawn from the instrument's results are meaningful and appropriate. Let's try to understand the concept of reliability and validity of an instrument by this dart game. Validity is how close you can get to the bullseye. So this shots should be nearer to the bullseye, that is validity. This is actually how accurate you are. And reliability is how much you can hit the same spot, how consistent you are. So in the first image, the player is consistent as all shots are nearer to each other, but not valid as they are quite far away from the bullseye. If we talk about the second part, the player is valid because the shots are nearer to the bullseye, but they are scattered. There is no consistency in the target and therefore not reliable. So the player is valid but not reliable. If we talk about the third image, all shots are lopsided. Moreover, they are scattered from each other. This means that the player is not reliable as well as not valid. So what we are actually looking for in the player is the shots should be nearer to each other and they should be nearer to the bullseye. So the player should be reliable as well as valid. The same thing is applicable to our instrument also. We have already discussed how to measure the reliability of an instrument. Kindly refer my previous video in the playlist. Now let's discuss reliability of an instrument with the help of this ruler example. Reliability deals with the consistency. Which ruler is reliable, ruler 1 or ruler 2? In ruler 1, we are having calibrations as 0, 1, 2, 3, 4, 5 and 6. In ruler 2, we are having calibrations as 0, 1, 3, 4, 5, 6. 2 is missing. The question is which ruler is reliable? Any guesses? Reliability deals with consistency. To the matter of surprise, both are reliable. Let's see how. Ruler 1 is reliable as it consistently gives the correct answer. And ruler 2 is also reliable as it consistently gives wrong answer. But we don't only require reliability, we also require validity of an instrument. So validity deals with the accuracy of the measurement. Ruler 1 is good, ruler 2 is bad, so it's not a valid instrument. Validity refers to the question of whether our measurements are actually hitting on the construct we think they are. While we can obtain specific statistics for reliability, even different types, validity is more of a global assessment based on the evidence available. There are three types of validity: content validity, criterion validity, construct related validity. For the third one, we can do the formal testing. Now, the construct related validity can be further bifurcated into convergent and discriminant validity. First of all, we'll understand construct validity. Construct validity examines whether the instrument truly measures the theoretical construct it is intended to measure. The example is, a depression scale should accurately reflect the construct of depression and not other related constructs like anxiety. Convergent and discriminant validity are subtypes of construct validity. This concept helps in understanding how well a test or instrument measures the construct it is intended to measure and how distinct it is from other constructs. Convergent validity refers to the degree to which two measures that theoretically should be related are in fact related. It demonstrates that the instrument correlates well with the other measures of the same construct or similar constructs. The primary purpose of establishing convergent validity is to show that the instrument accurately captures the construct it is designed to measure. This helps in confirming that the instrument is measuring what it is supposed to measure. Example: if you are developing a new depression scale, Convergent validity would be established if your new scale has a high correlation with the existing, and this will validate the depression scales. Now let's try to understand the concept of convergent validity. Loyalty is measured with the help of four statements: S1, S2, S3, and S4. The performance of the entire construct loyalty is measured by average variance extracted. Now, how we will calculate this AVE? So for this, we will assess the performance of S1, which is the variance extracted by S1. S2, the variance extracted by S2, S3, S4. So these are the performances. The minimum variance extracted by any of the statements should be 50%. Minimum should be 50%. Now, if I take the square root of 50%, that is square root of 0.5, I get 0.708, that is the loading. So the loading of each statement on the construct, the threshold limit is, it should be minimum 0.708. So if I take the square of it, the minimum variance extracted will be 50%. Now, how we will calculate the average variance extracted? Variance extracted of S1 plus variance extracted of S2, variance extracted of S3 plus variance extracted of S4 divided by 4, 1, 2, 3, 4. That is the average variance extracted. The minimum value is 50%. Discriminant validity, also known as a divergent validity, refers to the extent to which measures of different constructs are not strongly related to each other. It is evaluated by comparing the correlations between the indicators of the same construct to the correlation between the indicators of the different constructs. The purpose of establishing the discriminant validity is to demonstrate that the instrument is distinct from the measures of unrelated constructs. By showing big correlations with the unrelated measures, researchers can ensure that their instrument accurately captures the unique aspects of the intended construct. Example: imagine you have developed a new anxiety scale. To establish the discriminant validity, you would administer your anxiety scale and also a scale that measures a different construct, such as self-esteem. If the correlations between your anxiety scale and the self-esteem scale are low, it suggests that your anxiety scale is measuring anxiety specifically and not overlapping with self-esteem. Let's try to understand this concept. Loyalty is measured with the help of four statements: S1, S2, S3, S4. Satisfaction is measured with the help of four statements: T1, T2, T3, T4. Now the high correlation among the statements of same construct is desirable. This is desirable. This statement should be highly correlated. This is also desirable. But this is not desirable, which means that the statements S1 to S4 should not be highly correlated with T1 to T4. So the high correlation among statements of different construct is not desirable. If this happens, this is known as a cross-loadings. So this is desirable, this is desirable, this is not desirable. Let's proceed further. For convergent validity, high correlation among statements is necessary, which will be established through AVE, that is average variance extracted. For divergent validity, low correlation among construct is necessary. For two constructs, we calculate average shared variance or maximum shared variance. To achieve the divergent validity, average variance extracted should be greater than average shared variance or maximum shared variance. Now, to achieve the divergent validity, it is necessary that the statements of same constructs are highly correlated. S1, its correlation with S2, with S3, S4, S2 with S3, S4, S3 with S4. So they are highly correlated. Now let's talk about the correlation of S1 to S4 with T1 to T4. S1 is very weakly correlated with T1, T2, T3, T4. Same way S2 with T1, T2, T3 and T4. This is desirable to avoid the cross loadings. There should not be any overlapping. Now let's take one example. Job satisfaction is captured with the help of, is measured with the help of 5 statements. JS1. All things considered, I feel very satisfied when I think about my job. JS2. When you think about your job, how satisfied do you feel? JS3. How satisfied are you with your current job with your HBAT? JS4. How satisfied are you with HBAT as an employer? JS5. Indicate your satisfaction working with HBAT. So we have taken the opinion of the people on the Likert scale. Organizational commitment measured with the help of 4 statements. OC1. My work at HBAT gives me a sense of accomplishment. OC2. I am willing to put in a great deal of effort beyond that normally expected to help HBAT be successful. OC3. I have a sense of loyalty to HBAT. OC4. I am proud to tell others I work for HBAT. Environmental perception. EP1. I am very comfortable with my physical work environment at HBAT. EP2. The place I work is designed to help me to do my job better. EP3. There are few obstructions to make me less productive in my workplace. EP4. What term best describes your work environment at HBAT? Behavior of co-workers. AC1. How happy are you with the work of your co-workers? AC2. How do you feel about your co-workers? AC3. How often do you do things with your co-workers on your days off? AC4. Generally, how similar are your co-workers to you? Staying intention is a construct measured with the help of 4 statements. SI1. I am not actively searching for another job. SI2. I seldom look at the job listings on monster.com. SI3. I have no interest in searching for a job in the next year. SI4. How likely is that you will be working at HBAT 1 year from today? So now we will go in SPSS. So these are the statements. And the opinion is taken on the Likert scale 0 to 10. To check the validity of an instrument, we will go in analyze and dimension reduction factor. If you want to test the reliability, you will go in scale reliability analysis. For validity, you will go in dimension reduction factor. Now transfer all the statements which are on Likert scale. Only the statements which are on Likert scale. Don't transfer any of the demographic variable. So transfer it into the variables. Now go in extraction. Click on fixed number of factors. There are 5 factors. How? Let's see. Job satisfaction is 1, 2, 3, 4, and 5. So these are the factors. So we'll specify the factors as 5. Continue. Rotation. Give the very max rotation. Continue. Scores keep as it is. Options sorted by size. Suppress small coefficients. Coefficients whose values are less than 0.5. Continue. Click OK. And I got the results. This is communalities. Total variance explained. Component matrix. Now you have to focus on rotated component matrix. This one. Right click on it. Copy it in Excel. So this is, I have already done it. Now we will calculate the average variance extracted. How we will do this? Let's see. Let's tally the figure. 0.801, 0.793, 0.777. Is it same? Yeah, it's same. Now let me copy this. Right click, copy, sheet 2, Control V. So this is the loading. Let me recall you. This is loading. Now I will take the square of it, and it should be more than 50%. So enter here power B1. B1 is the cell reference which we have given. Enter. Double click here. Now take the summation of it. So this cell is C6. So C6 divided by 5, because there are 5 statements. Let me zoom. Now this value, as it is greater than 0.5, so we have achieved the convergent validity. This is one method to check the convergent validity. Now we will see the another method. Again, we will go in sheet 1. We'll take the average of this. Average of job satisfaction, average of behavior of co-workers, staying intention, environmental perception, and organizational commitment. So average loading. So it's just the summation of this divided by 5. Now this value should be greater than 0.7. Why 0.7? Okay, see here, 0.7. So there are two methods. One, if you take the square of it, it should be more than 50%. And if you directly work on loading, it should be more than 0.7. So 0.779 greater than 0.7, it means that the convergent validity achieved. Now take the average of behavior of co-workers. It is greater than 0.7, convergent validity achieved. Average loading of SI greater than 0.7, convergent validity achieved. EP 0.791 greater than 0.7, convergent validity achieved. 0.772 greater than 0.7 achieved. Now take the square of it. So we get this figure. Variance extracted by GS. This should be greater than 0.7. 0.5. This should be greater than 0.5. This we have already seen. This one. Okay. Variance extracted by AC. Variance extracted by SI, by EP, by OP. So we are just taking the square of it, square of the aggregate. See, there is a difference. In the first one, we took the square of the individual statements. Here, we are taking the square of the entire aggregate construct. Now, the variance extracted by AC and SI. So what we will do, we will multiply this two. So we will get this figure. Now we will calculate the correlation between AC and SI. Correlation. How we can calculate? AC, the cell references are from C9 to C12, and SI, the cell references are D13 to D16. So we will calculate the correlation. The syntax is correlation C9 to C12, D13 to D6. So this is the correlation between the statements. Now we will take the correlation square. To achieve the discriminant validity, it is necessary that this figure, the variance extracted by AC and SI, should be greater than this correlation square. In this case, it is less than, hence discriminant validity not achieved. Now you will have to repeat this process. How many times? Let's see. JS with AC, JS with SI, JS with EP, JS with OP, AC with SI, AC with EP, AC with OP. Then SI with EP, SI with OP, EP with OP. Now there are some advanced softwares like SPSS MS and Smart PLS, which calculate the convergent and discriminant validity directly. So it is necessary for the construct validity that we get convergent and discriminant validity. In case if you don't achieve it, then there are some remedial measures that we will see. Remedial measures to improve convergent validity. Item refinement and revision. Ensure that the items in the instrument are clearly aligned with the construct being measured. Revise ambiguous or unclear items to better capture the intended construct. Example, suppose we are developing an instrument to measure the job satisfaction. We notice that one of the items, I feel good about my job, is too vague. We will revise it. We revise this item to be more specific, such as I am satisfied with my current role and responsibilities. Increase item homogeneity. Enhance convergent validity by ensuring that all items in the instrument are consistently related to the same underlying construct. Remove or revise items that do not align well with others. During item analysis, we find that the item like I like my coworkers does not align well with the other items focused on job satisfaction, such as I am satisfied with my salary and I feel valued at work. Modification. We remove or revise I like my coworkers to ensure that all items are consistently related to the same underlying construct. For instance, it could be revised to I feel that my efforts are recognized by my coworkers. Conduct pilot testing. Pilot test the instrument with samples similar to the target population to identify items that do not perform well or do not correlate strongly with others measuring the same construct. We pilot test our job satisfaction instrument with small sample of employees similar to our target population. We identify that the item I look forward to coming to work does not correlate strongly with other job satisfaction items. We decide to revise or remove these items based on the pilot test results. Use established measures for comparison. Administer the instrument alongside established measures of the same construct to analyze correlations. Adjust items based on the results to ensure they correlate as expected. We administer our job satisfaction instrument alongside an established measure of job satisfaction, such as job descriptive index. We analyze the correlations between our instruments and the JDI. If our items correlate strongly with the JDI items, this supports the convergent validity. Based on the results, we adjust any items that do not correlate as expected to ensure they align well with the established measures. Remedial measures to improve discriminant validity. Administer measures of unrelated constructs. Assess correlations between the instrument and the measures of unrelated constructs. Ensure that the correlations are weak to establish discriminant validity. Suppose we have developed a new instrument to measure job satisfaction. We might also administer a measure of physical health, which is theoretically unrelated to job satisfaction. We would expect the correlation between job satisfaction and physical health to be weak or non-significant. Modify items to reduce overlap. Review items in the instrument to identify any that may inadvertently measure aspects of the unrelated constructs. Modify or remove such items to enhance distinctiveness. After administering the job satisfaction instrument, we notice that an item like I feel energized at work might overlap with physical health. We can revise these items to focus more on job specific aspects, such as I feel motivated to complete my task at work. Conduct confirmatory factor analysis to statistically test the extent to which factors are distinct from one another. Adjust the models based on results to improve discriminant validity. We conduct CFA on our job satisfaction instrument and other instrument measuring the workplace stress. We analyze whether the items for job satisfaction load onto one factor and the items for workplace stress load onto separate factor. If some items are cross-loaded on both the factors, we might need to revise or remove those items. Evaluate cross-culture validity. Assess whether the instrument performs consistently across different culture or demographic groups to ensure that the cultural factors do not influence validity. Our job satisfaction instrument is tested on two groups, one from the USA and one from Japan. We evaluate if the factor structure of the job satisfaction instrument is consistent across both the groups. If we find that the cultural factors are influencing responses, we might need to adapt the instrument to ensure it is culturally neutral. So thank you all of you. This was all about how to test the convergent and discriminant validity of an instrument in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias. Link given in the description box.